The objective of this rolling job is to roll poles. The equipment used includes a wrapping machine, a rack with rolls, a rack with fiberglass cloth components, and a bin for fillers. The tools used include a razor blade, a crank handle to adjust cloth, and a computer. The materials used include a pole, 66 inches in length and weighing 2 pounds was observed. Poles can weigh up to 21 pounds. A main pattern of fiberglass cloth. Filler. Tabs. Acetone, which is positioned on the edge of the main pattern, and tacking resin, which is positioned on the inside filler so that the filler sticks to the pole. The personal protective equipment included safety glasses, floor mats, and hearing protection is available, but it is not required in this room. The work environment is an inside work environment with heat and air conditioning. The worker observed was 5 feet 10 inches tall. The work methods for the observed rolling job include getting 2 poles from the rack, carrying those poles to the wrapping machine, positioning pole 1 on the wrapping machine hooks, positioning pole 2 on the wrapping machine work area, getting filler and positioning filler on the end of pole 2, positioning pole 2 in the wrapping machine, activating the wrapping machine with a foot pedal, getting pole 1 from the hooks and positioning on the wrapping machine work area, getting filler and positioning on the end of pole 1, removing pole 2 from the wrapping machine and positioning on hooks, positioning pole 1 in the wrapping machine, activating the wrapping machine with the foot pedal, removing pole 1 from the wrapping machine and positioning on the hooks, getting the main pattern from the rack, positioning the main pattern on the wrapping machine, getting the razor blade and cutting 0.25 inches off of the tab, removing the tab from the main pattern, positioning the tab in the garbage, getting a brush with acetone, painting acetone on the long edge of the main pattern, getting pole 1 and placing on the main pattern in the wrapping machine, activating the wrapping machine with the foot pedal, getting filler and placing on the end of pole 1 while it is in the wrapping machine, removing the tab from the next filler, positioning the tab in the garbage, removing pole 1 from the wrapping machine, visually inspecting pole 1, sending pole 1 to the next station, repeating these steps for pole 2. There were several ergonomic risk factors observed for the rolling position. Repeated and sustained exertions were rated as a high pace. Hands were in constant, rapid, steady motion and exertion to position and secure fiberglass material on the pole. This work is self-paced. Sustained exertions were observed and included continuous standing and continuous forearm pronation, or palms down. Forceful exertions were required to lift, carry, and position poles. Poles can weigh up to 21 pounds. And to transfer poles to the next workstation. Awkward postures were observed and include torso flexion or forward bending to position filler, torso flexion, extended arms, and wrist extension or backwards bending to position poles on hooks, elevated arms and mild torso flexion to get filler, torso lateral bending to position tabs in the bin and to view materials on the work table, torso flexion, extended arm, forearm rotation, and wrist extension to position acetone on the long edge of the main pattern, neck flexion to view materials on the work table, and torso and neck twisting to get and position materials. The mechanical or localized contact stress observed was contact stress between the hand, forearm, elbow, and torso and the tabletop of the wrapping machine front plate. The recommendations for the rolling job include: consider reducing the width of the front edge of the rolling machine and/or utilizing a retractable, adjustable width tabletop surface to decrease posture stress and localized contact stress. Investigate using a laser gun to guide the position of the materials on the poles to decrease posture stress. Consider using a pneumatic crank to adjust the machine height. Workers are more likely to use adjustable features if they are easy to use. Investigate automatic methods for ejecting and transferring poles to decrease posture stress and forceful exertions. Consider positioning the fillers in a belt pouch to decrease posture stress. Investigate automation assistance for positioning materials to decrease posture stress, repetition, and localized contact stress.